All right, welcome back. We are OOP3200 in the fall 2020 semester, and it's week 6, part 1 of our broadcast. Might be the only part. We're going to be talking about C++ generics. That's including template functions and template classes. So that's where we're going to be talking about that today. So this is what we're reviewing, generics, and there's going to be an in-class exercise number 5 for today. We're sitting at week 6. That's October 14th today of 2020. And what a wonderful year it's been. This is a more challenging level of topic today. Next week is also kind of interesting because we're going to be talking about additional template classes, standard template classes, and other kinds of in the STL, there's going to be different kinds of containers that we can look at. So in addition to what we talked about in week 5, last week, we talked about the vector. We kind of talked about that early. But next week we'll be talking about linked lists, stacks, queues, maps, sets, a bunch of other stuff. And then you'll have your in-class exercise number 6, followed by your a C++ 5, a lab, and as well as a quiz. That's all happening next week. So it's going to be a busy week in terms of marks and so on. And you should get all your marks up to date by the 27th, if I'm not wrong. That's when the plan is for everything that's going to be out. So there's no OOP lab this week, but it's going to be busy. And I'm sure that every week is busy in this course. But I think it's good from a practice perspective. You have a chance to go through the exercises and practice away. A lot of it is just following along in class. Some people aren't doing that. Some people aren't submitting, even their classwork, and that's just, kind of a loss of 2% from nothing. So please make sure you submit. Usually I give you the week to do it. So, try and make sure you submit that. All right, so we're going to be talking about function templates, and I'm going to give you some examples of the swap function template, how that looks, how do we use operators in function templates, function templates with multiple types, and then we're going to overload them, and we're going to go into class templates. And the one thing we're going to be doing in the exercise today is basically converting our Vector3D class into a template. We'll attempt to do that. It is very daunting when you're converting a regular class into a template class, especially the one that we made or that I had for you. Why? Because it's massive, and there's a lot of little details, niggling details that will potentially go wrong, right? So we're going to go through it, and we're going to make a very simple example first with a Vector3D, and then we're going to get right into modifying things for a Vector2D. Okay, so that's what we're going to be doing today. But before we get there, I wanted to also mention, as I mentioned to the class earlier, after this semester and this half, the second half is going to be Java, because it's the kind of course this is. So in order for you to make sure you're prepared for Java, please download IntelliJ IDEA from JetBrains. Again, for you guys, that is it's going to be part of the fun. The next half of the semester is you're going to learn a new IDE. So I've already gone ahead and downloaded it. So here's what it would look like. So this is IntelliJ IDEA. And as an example, here's an example of our vector class. We're going to talk about this I've already made a math F and a Vector2D just to kind of show off what the differences between Java and C++. We're going to talk about this when we get together in the next half of semester. One thing to do though is you need to download also with this a version of Java, and the OpenJDK is what I recommend you download and install. So that's another requirement for this. So take a look at OpenJDK. So if you download OpenJDK, and this is something you want to do for next half of semester, where it says OpenJDK.download. And it says JDK and 9 and later, right? And you can see how to download the pre-built version and so on. It talks about it here. and it talks about how to install it and so on, right? So please take a look at downloading and installing OpenJDK. And that's what we're going to be doing in the second half. If you do it early, then it'll save us a bunch of time when we come to the second half. And I'm telling you, like, weeks in advance. So yeah, I know. So you're going to be, you're going to have lots of fun with it. Okay, so that is what's upcoming. Let's talk about what we're doing today, right? So I'm just going to close this off because that's like way ahead. So today we're going to be talking about generics in general. So really, function templates. I mean, and you guys, this is kind of a review for you. And I'm just going to poll you guys. Have you guys done function templates before? So maybe you want to put up a check mark if you've done it before, an X if you've never done function templates. Nicholas says briefly. How about the rest of you? Check mark if you remember, X if you completely don't remember, and it's like way back in the past, right? And you need a review. Yeah, so I thought so. So that's why I'm one of the things that we're doing today was we're going to review function templates and talk about what that is and how that works, and then you'll be able to see that again. So let's go to it. Thank you for the feedback. All right, so really what we're doing is we have this idea of a generic function that can work with different data types. So let's say we have a function that we want to work with a specific data type, and then we're like, you know what, there might be a cause for us to make an overload, right? And we keep doing overloads and overloads and overloads for the same kind of function. It comes to the point when we're like, we can probably write this better. We're actually duplicating all of the code inside identically, actually. So even every overload looks identical except for the data types, all right? And once we get there, once we go to do something like this, so here's an example of a square, all right? So we have a square, and we overload functions to make sure that it makes sense, right? So we have a square function. I'm just going to zoom in here. And this square function has an integer type, and it takes the number, right? And then what we do is we multiply the number, as an example, by itself, and then we're returning that number. Okay, square. Yay, awesome. But the problem with this is it's identical between this one. This should actually be a space in here. When we take the first version and the second version, it's literally identical in the pattern, right? The only difference is this right here. That's the only difference. And we get into this situation more and more. It's not just in this language, but in C# as well. You'll see that there's a call for us to create a generic when we have this situation occur, right? Because it doesn't make any sense. It doesn't make any sense at all for us to do something that looks like this, right? Especially when you have every type that you want to define. An integer, a double, a float, and other types, okay? Even your custom data types. That would be something that would happen as well. So it doesn't make sense for us to get into a situation like this. And this is where we have function templates. So function templates allow us to write a single function, right, to kind of cover multiple data types, right? That's what it allows us to do. And what we can do is it looks like something like this. So the syntax is a little funky. And again, this should be a little space here. The syntax is a little funky. So take a look at that. So we have template class T. By the way, the new version that we're going to see is also, you can also use template type name T. Both are equivalent. So let's use template class T because this is the one from the book. Template class T. T is your own custom name for the template. You can use whatever you want in there. T is just a convention. That's all it is. Okay. So this is the type. That's what this means. Template class T, where T is the type. So whatever the type is, that's what Square is going to return, right? And whatever the type is, that's what Square is going to multiply by itself in order for it to be returned. So that's the way it works. It's almost like you're creating a variable type, right? So the type can be variable. It can vary. It can be float, double, int, whatever. Okay. So that's unsigned int, and so on. You can have different ones, and that makes sense because we want to make our functions a little bit more flexible, and we want to write less code. We want to reuse our code more and more. So the way we do it is we put in angle brackets. The angle brackets itself are kind of denoting the template. We need to use the template keyword. That is something we need to use whenever we do it. And either class or type name is what we put in there. Okay, type name T. That's kind of as of C++ 11. I think it's even in the documentation here. So that's what happens. So again, what this is basically saying is T is substituted with the type when we declare it. Okay. So here's an example of how we use it. We say, all right, well, I want to pass in int y and as an example, and x and y. This should actually be a lowercase x. Sure. And we want to pass in x into square, right, as an example. And then y is equal to the square of x, kind of like a graphing function, right? We're putting y in terms of x. And we're passing in x as an integer, so what it triggers is that the square function, which is now a template, the compiler will generate this function on the fly. So that's what's going to happen. The function doesn't exist yet. And when we need to use it, what's going to happen is the compiler is going to parse through all uses of this type of function. And when we need to use an integer type function, it'll generate it. It'll include it. So it actually creates all the overloads for us. That's what it's supposed to be in some ways. Meanwhile, if I did this, so if I said double yd is equal to 6.2, we're going to put y in terms of d. D is now a double 6.2. What it does is it triggers the t gets replaced by double. That's what happens. T gets replaced by double in all instances where the t is. So we kind of inject t as an example through that little function. So this function is now generated. This one. Okay. So that's the difference between one and the other. All right. Here's an example of a swap function. Swap functions are actually something that's very common. There's also one in the standard template library. But here could be an example of the swap function. Let's just zoom in here for a second. So we have a swap function, and I want to swap A and B. Or I want to swap A and B, but they're strings, right? So here's an example of where we want to swap, but look at the body. The body's the identical way. It's exactly the same way from one swap function to the other, regardless of the data type, right? Again, this is a great use case, if you will, for templates. Why? Because the body's identical, and the only thing that can change is the data type. Once you have this situation, then you're ready to go with templates. Okay, that's how it works. So here's what the template class or template type would look like. So again, you do template, the keyword, class T or type name T, right? And then what you do is you put wherever the data type is, you substitute T inside there, right? So now this is exactly what we would expect. So T doesn't matter whether there's a string you're swapping or whether it's an integer, a float, double, whatever. Doesn't matter. It'll do the swap and it'll generate the proper function at compile time. Okay, which is pretty cool. There's also if you look at the algorithm header file, there is a swap function that exists that's already been written for us, and this implementation is almost identical to the swap function that's in the standard template library. Okay. How about using operators in function templates? Notice that we use the multiplication operator, the times operator, if you will, but it didn't matter, right, whether we have the times operator with integers, longs, and doubles. Where we have a problem with operators is what about if you try and multiply strings, right? This is where we would use things like exception handling. So if you pass something weird into a function, let's say, for example, I want to add two numbers together, well, that might work with strings too, because if I add strings, I actually concatenate them. That's okay. But what if I want to multiply two numbers together? Multiplying, and there isn't an overload like that for strings that I know of, right? So it would throw an error. right? And rightly so. What you should do is you should do some kind of exception handling. Actually, the reality is we should probably use an assert, which is a lot different than a try-catch and an exception. The reason why is because the assert will 100% stop, and it'll basically force the user to, or the user of our library, so the programmer, it'll force the programmer to kind of look at it and say, wait, this, here's a problem with our code. As an example, it's not going to work out. It's better for us to use an assert statement, and we'll see if we can do that today. All right. So again, we can use relational operators too, but only if it makes sense. If the relational operators have been overloaded, right? Sometimes we need to do that for special types, especially if it's our own custom data type that we're passing into the template, because it could be any data type, even our own custom ones. Example, I want to find the minimum size between two vectors. If I pass a Vector2D in here, right, here's an example of a minimum. This is a minimum function, right? So again, it takes any type, including our own types, right? So imagine if I passed in a Vector2D type, right, that we're going to be talking about today. It would work, right? Because it's going to be an array of type Vector2D. That's what I'm basically creating. I can send in the size, let's say for example 5 vectors, and I can say the smallest one is array 0. Now I need to have a comparison operator. That's what I need to have. I need to have all those things working, like the less than sign has to be overloaded for my vector, has to be, as well as the comparison equals operator, as well as comparison greater than. I probably want to have all that going in my Vector2D in order for me to use this thing. But if I didn't, let's suppose I have never overloaded those things and I can't compare two vectors together, then I would have a problem trying to put my own custom data type in here. But if it's something else, if it's an example of this would be if I was to pass in a float or a double as an example. Strings may not work. You may not have, it would work, but it may not make any sense contextually, because strings also have values, right? Because the characters can basically convert to a value. But what you want in here is some kind of feedback for the user to say, whoa, buddy, right? This is wrong, right? Because it doesn't make any sense. So be aware of this, that T can mean any type, even your own. Right? And that can be a real challenge. And this is one of the biggest problems with templates. We don't know what we're getting in here as an example. So let's zoom out again. So that is we can use a string for that as well. And one thing we can also talk about is, what about function templates with multiple types? So we have function templates that have, instead of just one type, we have type 1, type 2, type 3. They take different types, 3 different types as an example. So here's an example. We have this thing called echo and reverse. This is an example of a function. So we use the type template keyword plus in angle brackets class or type name T1 class T2 class T3. Right, so T1, T2, and T3 are our own names. This is the ones we've assigned. We can make anything we want here. We can say type 1, type 2, type 3. That's on us. However we want to schedule it. Typically, like I said, from a convention, we use capital T for type. That's a convention, but doesn't have to be like that. And some coding houses decide not to use capital T for different reasons. So class T1, class T2, class T3. T1 would be A1, so that's the parameter A1. A2 would be of type T2, and A3 would be of type T3. Now here's a thing that can happen. What if, as an example, they're all the same type? That could work. Or they're all different types. That can work too. Or two of them are the same. That can work. It doesn't care. That they don't compare. One type doesn't compare itself with the other to say they must be all different. It's just that they can take more than one type. And then in reverse order, in original order, it's A1, A2, A3 as an example. And then what we do is when we reverse it, it's A3, A2, A1. All right, so that's kind of echo and reverse. That's what this function does. It's pretty simple. But again, this is using 3 different types. All right, what about overloading function templates? That's totally fine as well. And one of the ways, this is kind of a bad copy, but one of the ways it can be done is where we have, remember, overloading works on the number and size of the arguments, right? So the types. So here we have a template function that takes 2 values. So they're both of type T, right? And here's a template which is the exact same thing, another function that's called sum. So 2 functions called sum, one that has 2 values and one that has 3 values. Again, you can overload template functions just like this, just like we normally would. And you can also overload functions that are not templated with template functions, right? So for example, you might have a template function that overloads, kind of a standard function, another one, right? If you really want to, you can mix and match is what this allows you to do. So again, you might have a program that contains regular non-templated versions of a function as well as a templated version. And the reason for this is because it makes it easier for the compiler in some ways, or if you want to direct the compiler, and it removes ambiguity. So there's the note that I put in, which is beginning with C++11, which you guys are all using, at least C++11. You can replace the class keyword with type name. That's kind of a very common thing that you'll see too. So type name T as opposed to class T, they're equivalent. There's no difference in the prefix, right? Okay. So that is function templates. Any questions around function templates before we move on to class templates? And then we'll get into the demo. And I'm doing it separately like this because I think you'll get more out of it when we spend more time coding, and going back and forth might be a real challenge. All right, so how do we feel about that? Are we feeling better now about templates? Check marks if you're feeling a little better, X if you're still really confused and you don't know what the heck this is. All right, yeah, that's good. So I'm getting some check marks. I'm also getting okay, so Gabriel, you're still a little confused. Gabriel, can you want to kind of mention what it is that you're still unclear about in the chat, please? Because I want to make sure we clear this up, because if you can't do this, then doing class templates are like way harder. All right, we'll talk about that. Need to reread later. Okay. All right, if that's all it is, we'll move on. Thank you for the feedback. All right, so we talked about function template, but what about class templates? Well, so this is the cause where we want to create a class, as an example. This is the case, and I want to create a class that the entire class, I pass in a specific data type. I'm going to use the same data type throughout the entire class. And what I want to do is I want to pass that data type to some of the functions that are in the class functions, including maybe the constructor, right? So let's take a look at some examples here. So when we declare a class, we still use the T1, T1, T2, whatever identifier you choose. That's kind of the same way we do it. And it's similar to declaring function templates. And this is an example of a class template with this class called simple vector. Funny enough, they use the vector example as well, but they've done it differently than me. And what this simple vector means is it's not the same as an example as kind of the way we've done. So they've created their own vector, as in a STL vector. That's what it is. So here's what this is the syntax. So template, we use the template keyword, class T or type name T. Okay, again, that would work either way. And then you have your class underneath it. Okay, then what you can do is you can pass in that type as an example to both your member variable declarations. So example, unique pointer, right? If I'm declaring a unique pointer, a pointer, that's what it's called, of type T. So this is a pointer array, right, is what I'm doing, a unique pointer array. And int, of course, array size makes sense to stay as an integer because it's counting how big the array is going to be. Again, we're making a simple vector, a simple array type or container type of our own here. Simple vector int. The reason why we're passing in int is because this constructor passes in the size of the vector that we want to create. Okay, that's the one. And then we have a const simple vector for our copy constructor, notice that we did not have to put in the angle brackets inside here at all. But we're going to see that that might be different with what we're doing. Also, int size. If I want to get the size of my simple vector, again, it's going to be an integer because it's ranged. It's going to return the array size, which is the private member variable, out, which is also an int. So this makes sense. And then we have an operator. We return a type of the data type that we want, and it says and operator, and we're overloading the subscript operator. That's what this is, with an integer. So we're passing in an integer, but we're returning back out a type, whatever the type is that's part of the class. So this is what this does. All right, and this little function here, what it does is it allows us to create, this is kind of like a .h as an example for our simple vector class. We're going to see other examples further on in the PowerPoint where this class is being used. Okay. Again, it's not as crazy at this point as it can get, especially when it comes to arranging things. Once we have an existing class we want to convert into a template, or even a function we want to convert into a template. Those two things, there's going to be a method that we're going to use to do this. Okay, so again, the above class is going to store of type t in a dynamically generated array. That's what this does, and we can use pointers with this as well. This goes through what this does. And so here, when we declare the class itself, we're going to use something that looks like this: simple vector, and then in angle brackets, double, string, char, or whatever it's going to be, the type that we're going to make of this simple vector, which is very similar to how we use vectors in the standard template library today. Okay, so the same kind of idea, but we can make our own little implementation of the vector, which is what we've done here. Okay, so this is how you declare an object of type simple vector double. So when I look at this, I don't just look at simple vector as the type. It's simple vector double that I look at. A simple vector of type double. Simple vector of type double. Simple vector of type string. Simple vector of type char, as an example, or car. So here's a simple vector of type double, and it's called dtable. I'm passing in 10 because that is one of the constructors, the size of my simple vector. So 10 doubles. That's what this simple vector is going to have. Okay. How about the square bracket operator? How do we overload that when we declare it? Well, first we declare it, which we've done. And then whenever we have a function, as an example, we need to have template class t outside of each function that we want to declare, that we want to use the template. So anytime we want t, that template data type, to be used instead of a function, we need to also use the keywords template and class t or type name t before the actual function that we're defining. Why? If I need to return t or take a t, as an example, this is an example of how this would be returning the operator, then we need to kind of prefix it with this. This is important. Okay, so and the name of the class itself, also, whenever we reference the name of the class, we also have to reference it with this angle bracket t now, because we're saying, okay, so for the class that is of type t, whatever type t is, that's where the operator, the subscript operator is gonna be there, and it's gonna return a pointer that's relevant to the type that we're pointing at. Okay, with the size of the type that we're pointing at. All right, so that is the example of an operator overload for the subscript operator with using template classes. Okay. And here, as an example, we have the constructor function down here. So this is the convert constructor, is what they call it, right? And what we want to do is we want to convert it to a type. So we're going to say, well, here's my type, my data type. Let's say is double, and it's going to have an integer of a certain size. Let's say, for example, five doubles. So array size becomes 5. We create a unique pointer. Unique pointer is a smart pointer type as opposed to a raw pointer. A unique pointer of an array of type double, a double array of size s, in this case 5, let's say, right? And then for every, we're going to do a for loop between 0 and array size 5. And what we're going to do is we're going to instantiate a new object of type t, double, right? And store it inside of the array. That's how this works. All right, so this kind of builds the array. I want to build an array of this big. This is what this does, and it does it by passing in the type that we need. Again, I don't think it's difficult to look at. It's difficult to implement because there's little niggling details that stop us from getting things done. Okay, a couple things. It says there's an exception of the rule when it comes to attaching a list of type parameters to the name of the template class. The list and the angle brackets that enclose it can be omitted whenever the name of the class is within the scope of the template class. It's in the scope of the template class. And thus the list can be omitted when the name of the class is being used anywhere within the class itself or within the local scope of a member function that is being defined outside of the class. However, you can also be explicit, and many times we are, because it's easy for us to see everything consistent as opposed to some things with the template T or kind of the angle brackets T inside and some of them without it. That becomes a little bit more challenging. So here's an example of a copy constructor. Notice that the copy constructor does not have angle bracket T as over here. It doesn't have that, right? Where a lot of times we want to include those. Okay, so we're gonna see this problem as we get to what can happen if we do or do not use these things as we go forward. Okay. Here's an example of a inheritance with using templates. So we know we have simple vector. Simple vector is kind of our own version, and here we have a searchable vector, something that is a more specialized version of the simple vector. Right, and again, we talked about inheritance. Whenever we inherit from a class, then the child class or derived class is fatter and is bigger from a memory footprint perspective than the base class or parent class. So we know that searchable vector is going to be more specialized as well. So here's an example. So we have template class T. Searchable vector is, look, it's inheriting from a public is an important keyword here. Simple vector T. So notice that that type is going to be passed into both the simple vector as well as into the searchable vector. So a double, let's say, as an example. So we're extending the functionality of simple vector so we can search it, right? So now searchable vector int s, we define an object of that type where and notice it kind of takes care of the simple vector constructor by passing in type T and s. And we're going to have our own constructor in here. The copy constructor looks identical, and we can have an additional constructor here where notice the additional constructor also passes in a reference to simple vector T, right, which is instead of the searchable vector. So here's an example of that, and there's an example on the next page on how to implement it, right, where we have searchable vector T. This is our constructor, right? Or a find item method. The find item method passes in the T as a data type, as an example, and then it returns either -1, an integer, or wherever the object is inside of the index in the list, okay, that we're creating. So that is class templates and inheritance. All right, so lots of stuff, and now I'm sure you guys feel a little bit more comfortable with templates, but there's nothing like actually doing it that makes it easier for us to understand. So let's get to that. So I'm hoping you've downloaded the example that I've put up online. Let's go there. So I've uploaded in this week's module. I've got an in-class template exercise 5. This is the submission box for you to submit your exercise, and then I also have a starter for you to download. So please download the starter if you haven't done it already. Okay. I have, and it starts off like this. I have the exact same starter that we had last week. Nothing has been changed. This is exactly what we had last week. I'm going to put this up on GitHub immediately. So I'm going to do an add to source control while you're doing your download. Okay, and it says, do you want to save? Yes, I do. I'm going to add it to my Git repository. And then what I want to do is I want to go publish to GitHub. And I'm going to go to our GitHub organization, which is Durham Programmer. And I'm going to make this OOP3200 F2020 ICE. It says version 2 because I've been working with version 1, and version 1 was not successful the way I had done it, so I'm going to do it again with you. So I'm going to call it ICE 5, so you can see it up there if you want to compare my stuff with your stuff. Okay, so let's do that first. I'm putting it up online as we go forward. And once I have a repo, which I do, then I'm going to go up to the repository here. So I'm going to go to GitHub, and I'm going to go to Durham Programmer, and you're going to see that I have ICE 5. This is ICE 4 from last week. Here's ICE 5. One thing to note is some people got 0 on their in-class exercise last week because they literally gave me a fork of my repo. Please don't do that. That's not the exercise here. Don't just fork my repo and hand it back to me. Although it's the same, it's your opportunity to practice with C++ before you have a test and before you have a lab, right? So this is the practice. So please work through it with me as opposed to just fire it back at me. That's not the exercise, right? So if you did that and it was really apparent, that's bad. All right, so I want to get this link here, and I want to go back to here in my in-class exercise. I'm going to put in the link. So let's add a new URL. Okay, and we're going to put that link there for GitHub. So we'll say GitHub link for week 6. Okay, so that you have that link as we go forward. You just can look up here on inside of DC Connect, and you'll see the GitHub link for week 6. You can always follow along if you get lost, or if I'm going too fast, or if something works for me but doesn't work for you. Okay. All right, so what we had before was a Vector3D.h, and I want to convert this massive monster, right? This monster of a class. I want to convert it into a template class. We have a lot of conversion to do here, tons and tons and tons. And in order to make this simpler, let's start with something that is not as crazy. I want to make a Vector3D class, okay? And 3D is going to take 3 vectors, X, Y, and Z. Let's do that first. So I'm going to make a new header. Actually, I'm going to make a new class, and we're going to talk about the problems about doing this way. New class. I'm going to call this class Vector3D. Okay, so follow me here, please. I'm not going to inherit from Vector2D. I'm just going to make a Vector3D, brand new Vector3D class. It's going to be very similar to Vector2D for our coding requirements. And then I'm going to press OK. And when I do that, it's going to make a very simple Vector3D class with a .h and .cpp. I'm going to use the guard that I want on the top. So if not defined Vector3D, let's say. And I'm just going to make sure that I want to kind of follow the same way we did Vector2D. Notice we did Vector2D like that. I'm going to do Vector3D the exact same way. Okay. And I'm going to define it. So we're going to define. We're going to use this guard. It's important to use the guard. More so today than ever, you'll see. Okay, so that's kind of where we start every single time. We start with the guard. We use both the pragma ones and the if not defined pattern, right? So we cover both Microsoft, the MSVC compiler, as well as other compilers if we were going to take our code and make it more portable. All right, and again, I'm going to have 2 parts. I'm going to have a public section and a private section. Oh, there we go. I'm making it a class, all right? And let's define our private section with X and Y. So we're going to say, we're going to start with a regular type. So we're going to say float X, and we're going to make it so that it is M_X, just like we did before. Float M_Y, float m underscore z. All right. And I'm going to make a public constructor. So we're going to say a Vector3D, right? And the public constructor is going to have some defaults for this thing. So let's, like, we're going to code this as we normally would a Vector3D, okay? So we're going to say float x, float y, float z, where z is equal to 0.0f, and where y is equal to 0.0f, and where x is equal to 0.0f. So if I don't pass anything in, I'm going to just make it zeros. That's what I want. And I also want to make a destructor for it, right? Here's my destructor, and we're good to go, right? This is our little class. We can, you know, and I want to be able to return x, y, and z. Let's make a toString function right here. So we'll say a new toString function that returns a type string, right? So we'll include string type. There's an example of a standard template library object string, right? And we're going to have a standard string that we're going to return. This is going to be called toString, right? So we're going to return a string. That's going to be one thing. That's a thing that we want to print out what this thing is. I want to see what it is. Once we set it, we've done it. And I want to also have some getters and setters, right? Let's make a setter for this thing as well. So we'll say one setter. So the setter is going to return void. So we'll say here's mutators and here's accessors. You could do it the other way around. These are basically so mutators are setters and then getters. Maybe we want to put them as getters and setters because that's what we normally say. So accessors and then mutators, doesn't really matter. So in the accessors, let's do a get. So I want get x, y, and z as an example. So we'll say that. We'll say, but it returns a float, right? So get x, float, get y, float, get z. Okay, so x, y, and z this time, three-dimensional vector. And we'll also do void for the mutators. Set x, void, set, and x obviously should be whenever we do a couple things here. Set x, we're going to pass in a new float of type x, right? When we do that. And set y, float of y, and set z, float of z. And we know a couple things since we've been coding together that this should probably be a const function, right? Because it's going to return a const float, right? We know this is how we normally code, right? Actually, C# or C++ tells us this is just how it should be. And we know that there should be a const float when it's inbound. When we set, these should be const floats. Correct? This is normally what we see. Const in, const out, right? As the way it's done. Okay, so that's kind of a very basic class. And you know what we're going to do? We're going to go up here and we're going to use our lovely thing. And we're going to basically say generate definitions by declarations. And our lovely resharper utility, C++, will allow us to generate all this automatically. Let's do it. So here we have all this stuff. Let's do it. So we're going to say that in our vector x, y, and z, we want to say that m underscore x is equal to x, m underscore y is equal to y, and m underscore z is equal to z. Okay, so that's kind of how it's going to happen in our constructor. We can also notice that we forgot to put const on these because these also can be const. And ReSharper's suggesting that. I recommend that as well. This we're going to make a default constructor, a destructor for now. And get x, we're going to return m underscore x. Get y, right? Return m underscore y. Get z, return m underscore z. And set x, we're going to say that m underscore x is equal to x. And we're going to say that m underscore y is equal to y. And we have another one, m underscore z is equal to z. And our toString method, what we're going to do is we're going to set up a string. So we're going to say that standard output string, we've done this before too, is equal to, we're going to set that up as a standard string. It'll be okay. Right? Output string. Or we return the output string out here. Right? And what we're going to say is that my output string plus equals to, you know, again, open brackets, and then maybe the actual object itself, which is m_x. We'll use that for now. And then plus comma, and then plus m_y as an example. And then plus another comma, plus m_z, right? And then plus the closing bracket. Okay? So that is our thing, but we have a problem because it says, well, our output string says that when I look at this, when I'm trying to compile one thing to the other, what does it say? Expression must have integral or unscoped enum type. So what do I need to do here, guys? I'm adding in all this stuff, right? This is the output string, and I'm getting this plus, and this doesn't compute. What should I do? toString? I could. So what you're saying is do a standard toString in here. So standard toString, which basically wraps this one up. And I'm going to do a standard toString here. We're going to have some fun here. toString, which is going to wrap this one, and a standard toString that's going to wrap this one. Because it makes sense. These are all things we've done before. There should be nothing new here that we're doing. Completely nothing new. I'm just running off the screen here. But that's really what output string is, right? And it says, hey, you know, you might as well combine these two things because they're right next to each other. Heck, if I'm going to go there, I might as well just put, you know, everything in one line, right? Where we just output this whole thing here, right, in one line. I could do that too and not even use a variable and save us some memory. So if I was going to do that, I can take this whole thing, chop it up as an example, and just output like that, right? And let's see if that actually works. So, yep. So we don't need this anymore. And we can see that this is going to be a standard string, right? So that's what it's going to do. We can return in one blow everything that we've done before. Also, maybe what we want to do is, because this is a standard string, we can decide whether we want to put a backslash or not. All right, so we've got our basic stuff. One more thing I'm missing probably from this Vector3 as an example is I want to make sure that we have a setter that does all of them. So we have set x, y, and z, and I just want a set function. So one more setter, void set by itself, and we'll say const float x, const float y, and const float z. Okay, so that's another one, another setter, but it's going to do all three, right? And you can have various variations here. You can have a set that does, oops, undo. You can have a set that also does only two, you know, as an example. But we're not going to do that either. So I'm going to say m_x is equal to x, right? m_y is equal to y, and m_z is equal to z. Okay, so x, y, and z. Done. All right, so this is kind of something that we want to make it, and we want to test it. Let's test this funky thing out. Notice it says toString, and then it gives me some kind of warning. It says make member function const. Makes sense because it would be returning const. It's a const string that we're going to be returning. I'm totally fine with that. So we got our Vector3, but it's way simpler than our Vector2. We don't have plussing. We can't add vectors together. We don't have a lot of stuff. We want to start simple. And then what we want to do is after we do the simple stuff, we want to add things to it. So in our main, let's do a couple of modifications to main. Okay, so in main, where we go down into this part, I'm going to comment all of this out. So I don't want to test all of this out, my game object and all that stuff yet. I want to comment it out, and instead I want to test out my simple vector that I made, a Vector3. So I'm going to say that, hey, I want to use a Vector3D. I want to define it as 0.1, right? And it says include Vector3D.h. Yes, I want to. And I also want to say Vector3D 0.2. Let's define what they are. So this will be like 10, 100, 10.0 F and 100.0 F. And this will be like, I don't know, 5 and 20, let's say 5.0 F and 20.0 F. So that kind of does 2 points that I'm using the constructor in. I could have used the empty constructor too, you know, but we're not going to. And we're going to print those out. So we're going to say standard cout 0.1 dot toString. Right? And standard cout 0.2 dot toString. Okay, and see what those look like. Right? So that's pretty simple, right? And this is the good way of testing them. And if I hover over, it says that we should add const. Sure, I'm okay with that. Let's add const. And everything is beautiful, everything is wonderful. We love the world, we're good. And if I run, we should get no errors, and we get this, right? We haven't limited it in any way. It's just going to print out these large numbers, and away we go. All right, now that we know we've tested floats, let's convert our Vector3D into a template where it can take integers, floats, doubles, unsigned ints, and so on, right? Some other things. How do we go about it? Well, we start with our Vector3D class. So let's go back to our Vector3D class. And in our Vector3D class, on the top, we start typing template. Template, right? In brackets, again, class T, right? And it says provide sample and template arguments for IntelliSense, not yet. We'll go back to that. So now what we do is we pass in type T, and I want to replace all instances of the word float with T. Okay, let's do such a thing. So we'll say this will be T, and this will be T, and T, and we're going to run into some problems, and I want you to help me out here, and if you can spot some of the issues we're going to have as we get through, a lot of this stuff that you're going to see might be an issue. Okay, it's just changing all the floats to T's, right? Strings stay the same, these become T's. Okay, and now that we've done this, it says, well, none of those things exist anymore because you're done. And by the way, here's a problem. I'm taking T and I'm setting it to a double, a float. What if it's a double? It's going to shorten it. I want to make it whatever the type is. So let's cast it as a type. We'll start off with the largest double. That's my thoughts. We'll start off with a large double, and we'll make it into whatever it's going to be. So what I mean by that is I normally want to cast. Casting isn't liked by C++, our little resharper. It's recommending static cast. I'm okay with static casting. Let's make it the largest type that we can. So a double, right? Because that's going to be an issue for us, right? And we want to do the same thing for our defaults for this one, because these are our default values, right? And we want the default values to match our type. So we're going to say we're going to cast it as whatever the type is. If it's an integer, we're going to downcast. If it's and we're going to narrow the scope. If it's a float, we're going to narrow the scope. Less precision. If it's a double, we'll keep it as a double, right? And this way it doesn't matter. But now we're running into some problems. It says, look, these things don't exist. Well, that means, doesn't it mean that we have to change our Vector3D.cpp? And sure enough, it shows us we have issues, right? Why? We need to put in front of all these things, right? This is on the CPP side. Template, let's do this together, right? And then in brackets, class T, right? And in front of anything that says Vector3D : our scope operator right here, right? I want to put in a T, right? So instead of doing them all manually, I'm going to select all, and I'm going to go Control F, and I'm going to search for Vector2 : and I'm going to replace with Vector2D. Let's try 3D. I did this with the 2D. Let's do it with 3D this time. We're going to look for Vector3D, and we're going to replace with Vector3D template and replace. And it says I got 10 occurrences replaced, and still we have issues. So let's keep going and see what the problems are, right? So, okay. So it says we did it here, and let me undo those changes because we didn't do it quite right. That's Control F. Let's do one more time. So we're going to say search for Vector3D, search for Vector3D : and replace with Vector3D the type : Let's try that again. So there's more. That's a little better now. All right, but we still have issues, right? It says that I don't know what this is here. Tom, what are you doing here? And why this has got to be T, right? These all got to be changed. By the way, you might think this is good enough, but you might see later on that it's not, and we'll talk about why. Vector3D, it says T, and then it's giving us an error here. Let's just make this so it is open bracket, close bracket. So we're not going to use that template. But our Vector3D type, it says, is not really computing for our. It says it should be Vector3D, this one, right? This. It's telling me to do something here, but I'm having a problem doing this. All right, so we'll talk about this in a sec, okay? I'm going to come back to the destructor. Let's keep going. So get X, it's returning M_X, right? So it says Vector3D, but it's returning the wrong type, right? So it should be of type T, right? That it's returning, because that's something that it's going to return. Return type T, it says, okay? And I'm getting errors everywhere. It says vector type, Vector3D, it says, is the one that's looking for. It says use type Vector3D T, right? Which is what we've done, but we're still getting errors. Let me just keep going here, and we'll go through the entire thing here, and we'll talk about what this can do. So T, 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 T. This will be const T, right? Float. And you can see we're still getting errors everywhere, but let's just go like that. And the reason why we're missing all this is because we have to put in a class, the template part, which we're missing. Okay, so that's why we're getting all these errors. Let's put those back too, because we have to also do this. So do this, and voila, and like this. That should clean up some of those errors, right? As we're replacing stuff, and you're going to think that everything is golden after this, right? Because it's like, hey, it's beautiful, isn't it? And you can see the work we're doing just to convert a little class into something that's workable. Yay, it looks fantastic. It looks so good. I'm so proud of myself for getting this done, but it's wrong, guys. It's wrong. Okay, before I compile, can I please push to get? I will. Let's do that now. Well, when I'm done. Before I compile, though, actually, let's do the preliminary version, I'll say. So I'll go to Team Explorer. I'll go to Home, Changes. I think I've saved everything. And we'll say added Vector3D template version. Okay, template class. We'll say version 1, first version, right? And commit all, home, sync, and push. And you should have everything up online now. in a second. There you go. You should have everything. But there's a problem here, guys. There's a huge problem. Can you tell me what you think, if you know a little bit about the code, can you tell me what the problem might be? It looks identical. I mean, this looks pretty good, right? We have all our mutators and everything else. Everything's got T's in them. I'm really excited about it, you know, as an example. But when I run it, I'm going to get some errors. And it says there's build errors. Would you like to run the last successful build? No, I do not. I want to fix them build errors, right? What does it say? It says use of class template requires template argument list. Okay, that's the first one we got. So let's go to where that is. So it says Vector3D. Well, there you go. So that's the first problem we have. The first problem is inside main. We haven't told main what kind of type we're casting for. So I'm going to say that, well, my Vector3D is of type float, right? My Vector3D is of type float, right? Because we want to keep everything the same. I just want everything to work as before, okay? All right, let's recompile and see what happens. So we're recompiling, and what the heck is this now? Unresolved external symbols. What did I get this for? How come am I getting these errors? Guys, can anyone understand? Don't look it up. Tell me why you think this is wrong. Why you think this is a bad thing. Why are we getting unresolved externals? Can anyone tell me? And you're going to get them if the way we did it. Okay. Well, no one seems to be offering up a hint. Let me give you a hint. Remember that the compiler is generating things. No. No, that's not the reason, Nick. Not exactly. The compiler is generating things on the fly, right? It's generating things on the fly. So the compiler needs to have everything to generate nicely in one place. Separating it with a .h and .cpp, the way we've done it, it's nice for a non-templated class. But for a template class, my friends, they have to be in the same file, right? There's other ways around that too, but let's do that. So what we're going to say is you can't have this situation happen, right? Because then what's going to happen is that the compiler can't find the instance of the class, this version, if you will, of the template. It can't fill in the template when it's separate. That's why it's unresolved external. That's what it means. So I want to take all this. That's what it's asking me to do. Cut it, right? So I got nothing in my .cpp anymore, and put it in the same class just before the end if, right? I'm going to make a little note that says something like implementation section. Remember, this is for template classes, and paste. All right, so I've just taken everything and pasted it right in here. Okay, so no unresolved externals, guys. No unresolved externals. We don't want that kind of stuff to happen. Okay, so now that I've done this, I can safely get rid of the CPP. So we'll get rid of this, and we'll just get rid of it from our Solution Explorer. So in our Solution Explorer, we're just going to go to right-click on .cpp for Vector3 and delete. Remove, delete. Let's try it again with just the .h now. Right? Now, there's some dangers around this. We know that there's dangers around having too many includes in the .h. And this is where template classes can be a little tricky to use, right? You know, when we include stuff. So let's run it, and let's see if this runs now. And sure enough, it runs exactly the same way as it did last. Okay. Yeah, so that's it. Your toString is not working. Okay. I don't know why your toString is not working, but my toString is just like this. There's no difference. Please take a look. Let me put this up online. You can check my code. So I'm going to go to, again, Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to say Updated Vector 3D Template Class. Commit all. Right? And I'm going to go Home, Sync, and Push. All right, let's keep working it. I'm starting this from scratch, right? So I like this. This is nice, right? But I want to have a you know, just like we did with my friend operator here, I want to start thinking about getting inputs. And I want to do this friend stuff, right? I want to do the friend O stream and is stream. I'm going to need the IO stream in here. So let's grab that IO stream and put it inside of my Vector3D.h. All right. And down inside of the definition section. So this is the definition area of all my stuff, right? I want to have, just like we have here for the in the Vector2D.h, I have these two friends functions that allow me to do input operator overloads. I want to grab all this, right, and put it inside my Vector3D before the toString method. Okay, I want to do this. Okay, and we're going to say Vector3D is this, and Vector3D is this. Okay. Okay. And you know what I want to do? I want to generate them, right? And I'm going to say something like generate inline implementation. Guess where it puts it? Right in here. Why? I cannot separate this. This is another issue. If I tried separating the implementation from the declaration for my operator, which is a friend, it will fail. It'll give me an unresolved external. So now you also have to do this when it comes to template classes. Okay? That's what you can't just declare it and do it like this. This is number one. Two, we're getting a Vector3D, right? Do we need in our Vector3D to declare the type? Remember we said that inside of our class, when we do any of this kind of stuff, then it shouldn't matter. Let's see if that's true. And let's get some stuff going on. We're going to copy the stuff that we have from our Vector2D.h, right? Because remember, we're going slow here because we want to convert our Vector2D.h into something like this too, right? So we're going really, really slow. So here's our Vector2D.cpp. And our Vector2D.cpp, we have that stuff, all the goodness from our our operators. We don't have to reinvent the wheel. Here's this. So we'll say this is our out, and we'll do the same thing inside of our Vector3D.h in our out string. So here's out, right? And we're going to say in our in string, which is in our this one. This is a little bit more complex. Let's grab this. And we're going to go back into our Vector3D.h and put that in there. And you know what? We need to ignore another in because we're going to have in ignore another input. It could be anything we want to ignore, and we want to go and put in right hand side dot z m_z there. So this is what we want. Okay, so this is kind of would satisfy the requirements for a input and output operator. No? Okay, so think about this now for a second, right? Is it going to work? It's not giving me any errors. Doesn't mean that it's right. Okay, so let's run this thing and see what happens. First of all, we haven't accessed those things, so we're okay. So far it just builds. Let's access these things by modifying our main, right? So what I want, instead of doing 0.1 toString, let's just try just doing one of these. So say 0.1 and 0.2. We're not getting in stream yet, just out string. Does this work? Can I do that first? So if I run it, then we go out, and yeah, we're pretty good. That worked, and we didn't have to put in the type. All right, on that then, I guess we can get the type, right, from our 0.1 and 0.2. Let's steal some code. So remember that we asked for some stuff up here in our build game objects thing, where I asked them to enter the game object's position, right? I want to enter this, and I want to kind of steal this part right here, this part, right? So let's grab all this, and let's go down into our code here, and instead of having a fixed number, we're going to say this should be actually above this part. Sorry, should be here. And we're going to say that enter 0.1s. We'll say 0.1s position X, Y, and Z. So we know it's our special point 1. Here's point 1. And what we want is this is not going to be const anymore because we can't modify something that's const, right? And let's also inside here not define what point 1 is. So we're going to make it so it's the empty constructor. And same thing with point 2, right? Here's point 2, the empty constructor. And let's do one of these. And we'll say point 2's. And this is going to use our overloaded input operator. Okay, this is kind of an important thing. Point 1 and point 2, we'll also put in a standard cout, some decoration, which allows us to kind of do, you know, separating this so that we can say from input and output. We'll give an extra \n, right? There we go. There's an extra space there. Okay, so we're entering point 1's position, X, Y, Z, and entering point 2's position, X, Y, Z. And we're getting point 1 and point 2, and we're going to print them out. Simple, very simple in and out kind of calculations. Let's do that. So run. X, Y, Z. Okay, let's try this out. So I'll say 1, 2, 3, 4, 5, 6. Enter. And we got it, right? It works. So it's like we didn't have to use a T in there. It still did 1, 2, 3, 4, 5, 6, and we're good to go. All right. So these are in and out floats, no problem. It looks like it's working well. We haven't limited our precision. We could. We're not doing that yet. But that's definitely something we've done, right? And ins and outs, that operator in the .h, this thing here, works without our T in front of the class. Right? We don't have to put T in there, right? And this is working okay. So we're learning some stuff. We're learning that that's okay. Let's try different types. Instead of making it a float, as an example, let's make it an int. So we'll say that point 1 is an int and point 2 is a float. All right, so let's do that. So I'll run. And we'll say 1, 2, 3, 4, 5, 6. And when we get back, we get 1, 2, 3. Get an integers back. 1, 2, 3. And 4, 5, 6. Notice that it is a float type. So we get back. So far, so good. Are you with me? Check mark if you're with me. X if you're really far away and don't understand what's going on. So yeah, I mean, hopefully this is clarifying how the template class works. We're creating a generic class that can take different data types. Thank you for that feedback, guys. Right? And the generic types that we're getting, we can use any of our standard data types in there, and we can also use our own data types. Right? So be careful. We can mess things up a lot. Right? Okay, cool. So int, float. Let's also do a double. So let's do a Vector3D that is of type double. Let's look at the difference all in one glorious example. These are pretty good, right? And X, Y, Z or Z. And we'll print these out here. 0.3, right? So 1, 2, 3 points. And you can see that these are all different types. Run. And we'll say 1, 2, 3, 4, 5, 6, sure, 7, 8, 9. 7, 8, 9, and 4, 5, 6 look similar because of they look like they're doubles anyway, right? 1, 2, 3 is whatever it is. The other thing is that let's think about using some other odd things. What if I made int, float, and double, and I changed my double to a string? Can I do that? Can I pass a standard string inside of 0.3? I can. What the heck is this going to mean, right? Let's see what happens when I try and pass in a string. So run it, and string cast cannot convert double to T, right? So this means this up here, static cast, it's like I want to convert my double to a string. Static cast won't do that. So it won't allow it because just this alone won't allow it, right? Instead of static cast, I could use reinterpret cast. Let's try that instead. So reinterpret cast. I want to undo. Reinterpret cast. Right? I want to change our static cast to reinterpret cast. See if that makes a difference with strings. Is that going to make it? Guys, it's not going to make a difference. Right? Well, actually, it'll make no sense afterwards. Well, let's see what happens. Right? So again, no, reinterpret cast cannot convert double to T. Doesn't understand what that does. How can you convert it? Well, we don't know what those are. We can't get by this part because strings don't compute. Strings don't compute, right? And that's a huge issue. Huge issue, right? Unless we take a type that is, when it's an empty constructor, either if we want to take strings somehow, and we want to convert strings into, I want to take some other kind of thing, I could do that, right? I could, rejig this or make another kind of constructor for this. Let's do another one. Let's make it something that makes sense to you, right? So we'll go back to static casting these. But instead of, let's go back to main for a second. Instead of making our type, we're going to keep our type as float, right, as an example. But what I want to pass in, wouldn't it be nice if I can pass in a Vector2 object in here? So I can say, maybe I have a Vector2 already. So let's say I have a Vector2. We'll call it, I don't know, 2D point. Right? So here's my 2D point. Or point 2D. How about that? Point. Because 2D point doesn't compute. Point 2D. Okay, and I want to take my point 2D and pass it into my vector 3. Okay. This doesn't compute. There is no thing for this where I want to pass in my point 2D in there, right? And then, so let's not take in a value, right? And let's see if we can fool around with this. So this makes sense because sometimes I want to pass a 2D into a 3D vector or a 3D into a 2D vector. When I pass a 2D into a 3D vector, I don't have a Z coordinate, and so that should be 0, right? And my X and Y coordinate should translate over. It should copy over in there, okay? Let's fix that problem. So I'm going to go back into my Vector3D. I'm going to make a new, and why is it giving me lots of errors now? I do a static cast. Oh yeah, because of these errors that it's going to go away. So I want to make another Vector2D, Vector3D, but in this case I want to take of type a Vector2, Vector2D. I want to take the Vector2D as an object. Vector2D as an example. My Vector2D is going to be called, kind of a Vector2D, lowercase, right? I want to take this too. I want to take a non-type, a non-template type, right? I can do that too. Remember, you can mix template types and non-template types. I'll try a chart in a second. See what happens. All right, and let's see. It makes some recommendations. It says recommends Vector2D. I agree with that. And let's construct it. So we'll say generate implementation. It actually does it right here for us, right, where it says Vector2D, right? Generates it. And notice that Vector2D didn't complain. It kind of knows what Vector2D is, right? Somehow. But we'll, one thing to probably want to do is you want to probably include our Vector2D in here just so that way there's no issues. We're going to say Vector2D.h because we want to make sure that that is something we know about. And so here's our Vector2D. It says, shouldn't you want to copy this, right? It says create initialized field. Remember 2D, we want this, or comment the parameter name out, right? Remove the parameter name, right? Add may be used, and a clang tidy fix for this particular thing. It says to add an ampersand, which I agree. Ampersand means we're going to pass a reference to the Vector2 as opposed to copy the whole Vector2 across, which makes no sense, right? So then what we want to do is we want to say that our m underscore x is equal to vector2d dot get x, and m underscore y is equal to vector2d dot get y, and m underscore z, we're going to set that to equal to 0. Actually, we got to be careful here because we've got to set it to 0 but convert it, again back to what we did before with our other thing, right? Because we've got to make sure, kind of what happens. We don't have a z value, so the idea is that we probably want to do something like a static cast, something like this, not necessarily this. All right, so something like we want to static cast, the biggest value we can, a double, into whatever the t type is going to be. That's where we need the t, right? So we're mixing, passing in a Vector3D object with something else that looks like this. So if I go back to main.cpp, now we're okay with this, right? And we're going to print out 0.3. Let's see what happens. I'm not gonna play ball. Vector2D, let's give it a value. So we'll say Vector2D is going to have a value of 200.0f and 300.0f. So it's going to be, we're going to pass in these values. Now what happens with that, right? Because we're going to try and convert. That's another thing. We're passing in a float type into a, could be a double type. We don't know what it's going to be, right? So that's another thing we have to consider. So going back to our vector3d.h, then what we want to do is static cast the other ones as well, right? Because we don't know what they are. We're assuming that they're compatible. We don't know what they are. But we don't know what our vector2d is right now, because vector2d is only float right now. So we're going to static cast it. If it's an integer, we're going to static cast it to integer. If it's a double, we're going to static cast it to double. We're going to lose some precision, right? If it's a float, it's going to become a float. Right, so that's kind of a little bit of a safety, but not much. Let's see what happens when we do this thing. Okay, so 1, 2, and 3, 4, 5, and 6, and we get 200, 300, and 0. 300, 200, and 0, because 0, there is no value when we pass in a Vector2D into a Vector3D, so it becomes 0. Nick suggested, what about char values, right? So let's see what happens if we did that. So if I go back into our main, and I want to pass in, a type of char into a 0.3. So let's make it so we'll do, 0.4. Vector3D, and we'll say char, 0.4. Okay, and we'll do the same thing. We'll enter 0.4 in there. So we'll get 0.4 is x, y, and z values, right? And let's see what that does. And we'll print out, if we get to that point, let's print out 0.4 and see what happens. Okay. And do we get there? Well, it runs. Char does run. So 1, 2, 3, 4, 5, 6. Let's do 7, 8, 9 for 0.4. 7, 8, 9. And it does weird stuff. It's like 55, 56, 57, because 7 is probably character code 55, 56, and 57. I'm not sure why you keep getting disconnected, Nick. I'm so sorry. A good thing is it's being recorded, so you don't have to lose much. Yeah. All right. So does that make sense? 55, 56, and 57, doesn't really compute. It doesn't compute to, what it is, right? So we can check for certain types. We can check. So if I wanted to take a string type in my Vector3D, I could make a standard type for this, right? Remember, we talked about mixing and matching types, all right? So let's go back to my Vector3D, and inside of my constructor function, I have a constructor function now that takes a Vector2D. Okay, takes this. It also takes type T. Right, some type T. We can also make it take strings, a large string value, as an example, string of X, Y, and Z, and see what that does. So I can make that happen too. Let's try it out and see what happens. So 3D, and I want to take another one that surpasses this one, right? And if it's specifically strings, right? And this is where we can get into some trouble, but let's suppose we have them. So we'll say standard string, and the standard string that we're going to have is for X, and standard string for Y, and standard string for Z. That's another constructor. So yes, another one, right? So again, we're mixing and matching template types as well as standard types or complex types. And let's generate in my implementation. Notice it gets implemented right here. And no, I'm not going to provide that right now. So how does X, Y, and Z work for me? Well, we know they're strings now, right? So I want to cast them. I want to convert them into X, Y, and Z. How do I do it, guys? What's my conversion? What do I do? How do I convert? How do I convert each of these values, X, Y, and Z? And what might happen? Remember, it's a string. It's not a into an 8 double float or whatever. Yeah, of course. But how do I convert? Do I just use conversion syntax like this? So I go like, okay, T X. So we're going to say M underscore X is equal to template. We're going to convert from X like this, and we're going to do a static cast. Right? Can we do that with a string? Can I convert from, can I convert from string to int or double or whatever with a static cast? Can I do it that way? Yeah. Let's look it up. So let's go. I want to convert string to double. String to double. Let's just start with the big one. C++. How does that work? Right? So there's a standard function, string to double, the string to float, and string to I, S to I, that actually converts all those things, right? So it's a standard string to double that we want to use. But guys, we have no clue what the type is, right? We don't know what the type is going to be when we convert, right? If it's double or an integer or a float, we can accommodate those things. But I want to convert anything, right? Any kind of my types, whatever my type is going to be. So there's a couple of options here. We depending on how we want to design our code, right? Let's try this and see what happens. Do we get a weird conversion? And the answer is going to be it's not going to work. But let's try it first. And I'll tell you that it's not going to work, right? But let's see what happens. Let's see, okay? I'm going to go back to main. And we're going to go put, instead of 0.4, make this a standard string. Instead of a thing. And it says like, wait, standard string. Wait a minute, right? It doesn't have a conversion for this when we pass in a type T. So this has to remain a float. This is the funny thing, okay? But I can pass inside the float, I can pass in a string. Like for example, let's pass in a string that is 4, 5, 6. Can I do that? So 4, 5, 6, and passing in actual characters. Let's not take them in from here. Just as an example, just to make sure that we can do this. 4, 5, or 6 as an example. There we are, right? And 4, 5, 6 is going to be converted, we're hoping, from a string to some kind of floating point value. Let's see what happens. And of course, we get this. Static cast cannot convert from standard string to T. Even if we use reinterpret cast, we're going to get a problem with this because it doesn't know what to do. Strings are complex kind of types, right? So that is an issue. I agree with this, that we should use our tidy fixes for all of this, which is we want to copy the string, make a reference to the string instead of copying it. That is an important thing to do, but this is not going to be any good. So what we want to do is we want to say, well, okay, we know that this is going to convert to float, but we want to compare what it's going to be, right? And there's 3 comparisons we can do, the typical ones that we know about. String to I, string to D, string to F. Those are the three that we know that we can do pretty easily, right? And we can also do other things, convert it to a C string and so on. But let's start like this. So if we can say type ID of T, so we're saying the type ID that is T, if that is equal to type ID of int, right? If it's an integer, right? Can we not do this? We not say that if it's an integer, then what we want to do is grab all this, put it over here. But instead of static cast, we want to do standard string to I, right, of x. We can do this, right? And what this does is specifically for each type, right? We can kind of go in here and, at least for the most common ones, and we can throw an error if it doesn't compute, if we can't convert from one type to the other, right? So we're going to say if this is that, and then, you know, if the type is a float, then now it's going to be string to F. Okay. And what about if it's a double? So if it's a double type, these are the ones we're checking, then we're going to use std. Okay. There we go. So those are the ones we can use. And that's what it'll do. This in this constructor, right? And let's run this thing and see if it does, if it works now. So again, 1, 2, 3. We'll do 5, 7, 8, and 4, 5, 6. Look at that. 4, 5, 6 came from a string into a double, no problem, or a float. Okay, so that's how we can convert them, and we can compare which one it's going to be. Let's try another one. So to make sure that this is the case, we're going to say that our type is an int, and we're going to say 0.456 is coming from a string to an int. How do I do that? So do one of those. So again, 1, 2, 3. We'll do 7, 8, 9. And we'll say, so 1, 2, 3, 7, 8, 9, 200, 300, and 4, 5, 6. Notice that 4, 5, 6 now is just an int. So it used this one, this part. But is there a way of converting, and I'm gonna let you go with this one, a string to a to the other type in a template? All right, so let's look that up. So string to type T and template C++. So let's see, it says get name of type in template, convert string to every type using template function. Let's take a look at that. So we've got a person that's kind of gone through and says convert string. So I've taken a string, which is a date. If data is empty, then if not empty, then don't do anything, because what if it's an empty string? And then it says what it's going to do. This is a way of doing it. It's going to compare, it's going to break down the string into its components. That's what it's doing. And then when it takes the string to its component, it's going to convert it into the other type, whatever it's going to be, right? So that's more of a custom type, a way we would do it, by taking the string's components and converting it. And I think this is not a bad idea. Okay, if you're going to convert it to any type. Okay. And that's just the first one we found. But this is okay if we know that there are only 3 types you're going to get. But what if there's a 4th type? And again, like I mentioned, what if it doesn't work? Oops, pull up Discord there for a second. What if it doesn't work, right? As an example. And what I mean by that is, like, they pass your peeps, you know, pass something at you that, you know, there are people that are using your code, and you know what? It makes no sense. Let's just say it makes no sense, but they're passing something into your code that's going to, you know, basically fail, right? It's going to fail. So how would that work? Is the big question, right? Because what you want to do more than anything else is you don't want you don't want things to fail, right? So how would that work, right? And one way we can do it is by using an assert. So let's take a look at asserts before we go. and then I'll give you a little exercise that I want you to do, your part, this time around. So if I was to do an assert, so C++, for those people who've never seen it, let's take a look at an assert and what it looks like. So here's an example, assert, and you can see that the it says my int is not equal to null, a true or false or whatever, right? That means if I pass in some other value, if it's and notice I can include assert.h, right, which helps me with my assert, right? So let's pass that in, assert.h, right? And it allows us to pass in, and this is only by the way, it says define ndebug. Ndebug is what's going to happen is if it'll disable all of them if it's not in debug mode, right? You can do that with asserts, which is pretty cool. So let's go back into making this work for us. So let's go into this, and let's suppose we're going to say assert, and we're going to pass in the up here assert.h. We're going to say I want to say that, and notice that there's an expression that I can put in, right? So the expression goes in here. So if you know, it's a false, right? And then what it's going to do is it's going to pass out a message, right? Which is what you want to do, right? You want to pass out a message, right? That is going to stop things from happening, right? It's going to actually interrupt your code, which in many ways is what you want. So something like if type ID is something else, right? So else, if it's something like, if it comes down to this point and type ID is not equal to int or float or double, let's do that. So type ID of t is not equal to type ID, let's just do this, of integer or a float. We'll say it's not this, or well, we'll say and. It has to be none of those, right? And it's not this, right? And it's not this. So type ID is something else, right? And you're trying to use this constructor. So this is the first part. You make the thing happen, and then you say error, no conversion possible. Okay. So what you're saying is connect, try and see if type ID is an integer, a float, or a double, you're good. But if it's some other type, then there's no conversion possible, and it won't work. Okay. This is an assert, and it's not like a try catch. It'll interrupt your code, which is what we want. Okay. So let's go back to our main as an example, and we're going to say that it's not an int, float, or double. We're going to make it something else, right? So let's think about what kind of ints I can make. An int, let's say an unsigned int, a uint. So I want to make an unsigned version. So uint, let's say 8t, something like this, a different type, right? An unsigned int, 8 bits, right? And 4, 5, and 6. I'm passing this in. I'm using this thing. We should get an assert now because it hasn't found, one of those types. It says debug error, right? Abort has been called, right? If I go to retry, right? First of all, it says assertion failed. Type, it's not this, right? And then it gives you, this message, right? It says so assert failed, as an example. Here we are, right? And this is good. This is saying like, something went wrong at this particular point, right? And here, what we have is kind of a little message. So there's my my debug, right? It's my debug error. It says that it's stuff. It's going to stop me from happening. And it's not going to be a random message. This is something that you and I generated, right? And so if I say retry, it's going to take me back to this right here where it says an exception has been thrown, and then it says no error, no conversion possible, right? This is good, guys. This is what I want. This is telling the developer that, hey, guy, you're trying to use something that we haven't really thought about using. Don't use it this way. This is a bad thing. Okay? That's definitely something we can do in our code. And I think asserts are pretty good like this. But this would totally be avoided, this part right here, because notice it's I'm going to do this, and then this is only if this is going to happen. It's going to avoid this little assert statement if I use an integer, a float, or a double, right? So if I go back to main, and if I change this back to, let's say, an int, right, then the assert is not going to trigger, right? The assert won't trigger now, right, like it did before, right? Or did it? Would it? Let's see. Oh yeah, of course it will, because we made it if one of those things, it's got to be all, one or the other, and I said all of them have to be true. Sorry, so that's my bad. These should be ors. So if this is not equal to this, and it's not equal to that, and it's not, they have to be not equal to any of these things is what we want. And we want actually ands. If all of these are true, it has to be all true for it to fail. If it's one, if one of those are true, then there wouldn't be a conversion. Let's try that again. Not equal. All right, so assertion failed. So sorry, let's do the ors. I was right the first time when I was thinking about it, because it's got to be one or the other. If one of these is one of these fails, right? If this is not equal to thing, or whatever the assert triggers, if one of these three is not the case. Let's see if that works again. Yay. 1, 2, 3. And then we'll say 7, 8, 9, and we'll convert it to 4, 5, 6. No problem, right? But once we put in some other value in there, right? Like I said, let's say we'll pull this into a char as an example. Chars won't convert, right? Because we don't have that kind of conversion. So 1, 2, 3, and then 7, 8, 9. It's going to say, it's going to try to do it. So char converts over. So it's going to be, we want to try and catch it. Let's see why this is happening. So either type ID is not equal to t, int, or if one of these things fails. If one of these things is true, right, then it's going to say error, no conversion possible. Yeah. Let's try another one. Maybe I did that wrong again. Sorry, guys. uint unsigned int unsigned int underscore like 8t uint 8t. That's what I want. Something else, because maybe char was misinterpreted. Let's see how that works. 1, 2, I don't think it's going to work. 7, 8, 9. Oh yeah, because it's going to try and convert it to twos. That's probably my logic. Okay. And I'm trying to look and see what this is. So yeah, so what I'm saying is if my type ID t, right, is not equal to this, right, any one of these can be true, right, if for it to trigger, and it's not doing my triggering, which is okay, right? But the idea here is what we want. We want to see that this is true or not true. And once we have the case here that it's not an int, a float, or a double, if it's not one of these three, right? If it's one of them, if it's equal, then this will fail, right? You know, as an example, if it's equal to an integer, float, or double, but if it's something else, then you know, it's not going to happen. You can also put multiple asserts, you know, if you want to do it, but this kind of idea is what we want. All right, that's it for me. So your homework, which is going to make it a little bit more challenging for you, is I've done the initial lifting on the Vector3D.h. Your job, it's not a lab, and it's optional. What I want you to try and do is I want you to try and convert your Vector2D.h, this large monster, by doing some investigation. There's no lab this week, But on your own, I want you to convert vector2d.h so that you can uncomment main.cpp. You can uncomment main.cpp, the bottom part here, and use it the exact same way it was used before, right? By declaring a game object, making a game object, everything that we did last week, I want you to do this week. And then you can comment out this part. We don't care about this. The Vector3D was our test to see how we can learn about class templates, right? Template classes. But what I want you to do is convert a more complex one, our Vector2D, for this week's in-class exercise. I want you to try that and submit what you can. If you can't do it, don't worry. Submit what we did today. But if you can, and make a comment. Say if you have done it, if you're able to convert it, make a comment in your submission for this week that says, "Hey, I made Vector2D work as well. Take a look, Tom." Right? And I want to see what you did. Okay? Guys, thank you so much. That's it for me for this week. I'm going to stop recording now, and I'm going to put this up on GitHub. So let's put this up on GitHub first. I'm going to go to Home, and I'm going to go to Changes, and I'm going to go to Updated Vector3D, Comment All, right? Home, Sync, and Push. And then you should have everything you need to get going on kind of the thing I've asked you to do today. All right, so let's just stop recording this and we'll go from there. All right.